Hi, welcome to my Capstone Symposium presentation. My name is Muwei Zhang, and the title of my poster is Life and Death: How Does Western Hemlock Mortality in a City Park Affect Pileated Woodpecker Livelihoods? I worked with Friends of Seward Park, an organization that focuses on the protection and management of Seward Park that is concerned about the current Western Hemlock die-off problem in the park's forest. As an important species in Pacific Northwest forests, Western hemlocks are suffering from a health crisis that makes them defoliate and die rapidly. Both living and dead trees are vital ecological components for animals living in the forest, such as woodpeckers. Woodpeckers have unique ecological functions and are considered keystone species. A resident population of pileated woodpeckers, the largest existing woodpeckers in North America, lives in the Seward Park and is inevitably affected by the hemlock decline. The increasing death of trees leaves unknown impacts on the woodpecker's life by providing potential food sources and changing the forest structure. To plan for the long-term conservation and management of this keystone species, it is important to know how dead tree status affects the woodpecker population. My research question is, what conditions and characteristics of Western hemlocks in Seward Park are associated with the forage activities of pileated woodpeckers on the trees? To get hemlock status, my coworkers and I identified every Western hemlock in the forest and collected a set of data including diameter breast height, that is a measurement of tree size, health score, latitude and longitude, and woodpecker damage score. We calculated the tree health by dividing the tree into 3 sections, upper, middle, and lower, and giving each section a score from 0 to 3. 0 means totally dead, and 3 means no defoliation visible. I designed the woodpecker damage scoring to be from 0 to 5, means 0 means no woodpecker foraging trace on the tree, and 5 means extensive woodpecker damage. I recorded any pileated woodpecker activity I encountered and set up camera traps to take photos and videos. I also reviewed literature on pileated woodpecker life history and Pacific Northwest forests for background knowledge. Now, let's discuss my results. Firstly, here is a map showing all the trees with documented woodpecker damage in the entire park. Each dot represents a tree. The sizes of the dots show the DBH of the trees, and the deeper color means a higher score of woodpecker damage. Some 116 trees were measured in 2021 and are excluded in this analysis because they lack the woodpecker damage score. The black circle marks the graveyard of intense hemlock mortality, while the green circle marks the garden with relatively healthy hemlock colonies. Many trees fall outside of these 2 ranges. Histogram 4 shows the number of trees with each level of woodpecker damage score among the deceased trees. I defined deceased trees by having an overall health score lower or equal to 0.5. We can see that the gray and black colors cluster at the right end of the histogram, which stands for the larger DBH. Histogram 4b shows the percentage of trees with defined by score larger than 0 and without, defined by score equal to 0, woodpecker damage corresponding to the size among deceased trees. The percentage of trees with woodpecker damage increases with the tree size. Deceased trees larger than 44 inches are 100% foraged by woodpeckers. Figure 5 are comparisons between the garden and the graveyard. From these graphs and other information, I come at a few takeaways. Pileated woodpeckers most intensively exploit large, relatively intact snacks for food in the park. This is also generated by my observation that most woodpecker damaged trees have an intact structure with remnant branches, indicating that they died not long ago. Next, 95% of woodpecker forage trees have DBH larger or equal to 20 inches and overall health smaller or equal to 0.5. Only trees that are both large enough and dead enough would be used by woodpeckers. Next, the likelihood of deceased hemlocks to be exploited by woodpeckers increases with DBH. However, due to a large base number of hemlocks with medium DBH, trees under 32 inches of DBH consist of the majority of all woodpecker trees. See figure 4. Then, although the total hemlock density in the graveyard is slightly lower than in the garden, the density of woodpecker damaged trees in the graveyard is over double of that in the garden. However, the deceased trees in the garden and the graveyard are used by woodpeckers at about an equal rate, while the percentage of deceased trees among all western hemlocks in the graveyard is almost 3 times of that in the garden. See figure 5. Last but not least, pileated woodpeckers mostly forage on parts of the tree with intact bark. That result is yielded from camera traps. I aimed the cameras on previously damaged areas on trees, but no woodpecker was caught working on those areas. However, I was confident that woodpeckers are still working on these trees based on observation. Thus, the woodpeckers must have been feeding outside of the camera lens on the intact parts of the tree. We may get some implications from the results. They reveal the importance of properly managing dead trees in urban parks and green spaces, and the larger dead trees should be reserved for pileated woodpeckers anywhere if possible. Then, the likelihood of pileated woodpeckers foraging on a dead hemlock is not significantly correlated with the density of other dead hemlocks nearby. Dead trees in areas with less other food resources are even more valuable for woodpeckers and should be kept. Western hemlock decline is likely not induced by the foraging activities of woodpeckers, because we found that woodpecker damage only emerges on already deceased trees. The trees die first, and woodpecker then excavate on them, not the opposite. Next, abundant recently dead hemlock trees offer increased food sources for woodpeckers in the park. Meanwhile, the long-term population dynamics of pileated woodpeckers need to be investigated to better understand the hemlock decline's deeper impact. Last but not least, nesting and roosting activities were not observed in this study period because it was in winter and when pileated woodpeckers were inactive. Thus, future research is expected to fill this gap of knowledge. Thank you for listening today. I want to thank my site supervisor, Paul Shannon, my faculty advisor, Tim Billow, my coworkers, Eric and Nate, Catherine Alexander, my friends, and my family for all the help and support they offered. It is impossible to complete the project without their kindness. Thank you.